Hello, welcome to our fourth part of probability. We have been dealing with probability, and in this case we are going to deal with the previous questions that have been tested on the Kcse, that is mathematics paper 2. That's where probability is usually tested. So we are going to deal with 5 of them, the year 2024. That is the current year as I'm recording, the 2023 question, 2022, 2021, and then the year 2020 question on probability. And you're going to start with the 2024 Kcse. The question reads, the probabilities of obtaining scores 1, 2, 3, 4, and 5 using a biased pentagonal spinner were recorded as shown in the table. So we have the score and we have the probability. Score 1, 2, 3, 4, and 5. So the probability of score 1 is K. Probability of score 2 is 0.1. The probability of score 3 is 0.25. The probability of score 4 is 2K. And then the probability of score 5 is 0.2. So we are required to part A to get the values of K, and then part 2 of A to get the probability of obtaining a score 4. Then part B, we are told that the spinner was spun twice. Work out the probability of obtaining an even number in the first spin and an odd number in the second spin. As we can see, we know that the probability lies between 0 and 1, and the probability of all of the scores 1, 2 to 5, they should add up to 1. So that is the idea that you should have before we answer our first one. K plus 0.1 plus 0.25 plus 2K plus 0.2 give us 1. So when you add the K plus 2K, that's going to give us 3K. Then 0.1 plus 0.25 plus 0.2, that one is going to give us 0.55. Then this one is the one that is giving us 1. So 3K on one side will be given as now 1 minus 0.55, which is going to be 0.45. So we divide by 3 on both sides. K will be equals to 0.15. So the K there should be 0.15. Then part 2, you are required to get the probability of obtaining a score 4. Score 4, we can see it is 2K there. So 2K, if K is 0.15, so 2K, that is the score 4, should be the 2 times 0.15, and this is going to give us a 0.3. So we have been told that the spinner was spun twice. Work out the probability of obtaining an even number in the first spin and an odd number in the second spin. What are our possible outcome here? We can have the first spin being 1. So let's list the possible outcome here. So you can have 1 with 1, the second one, or 1 with 2, or 1 with 3, 1 with 4, 1 with 5. So that is, can have 1 with that one, just listing the outcome. You can still have the first number being 2 with 1, 2 with 2, second spin, 2 with 3, 2 with 4, or 2 with 5. Then you can have 3 with 1, 3, 2, 3, 3, 3, 4, or 3, 5. Then you can have 4, 1, 4, 2, 4, 3, 4, 4, or 4 and 5. The last one you can have either 5 with 1, 5 with 2, 5 with 3, 5 with 4, or 5 with 5. So those are the possible outcomes. To answer our question, we are required to get the probability of obtaining an even number in the first spin and an odd number on the second spin. So the first spin, we either have to have 2 or 4 being an even number, and then the second number being an odd number. So in that case, we have an even number 2 with odd, that is 2 and 1. You can have 2 and 3 or 2 and 5. Then we can also have 4 with 1, and then 4 with 3, or 4 with 5. 2, 1, we add probability of 2, 3, probability of 2, 5, and probability of 4, 1, probability of 4, 3, and then probability of 4, 5. So probability of 2, 1, probability of getting a 2 is 0.1. So this is going to be 0.1 times probability of getting 1 is 0.15. Probability of 4, 1, 0.3 times 0.15, plus probability of 4, 3, 0.3 times 0.25. Lastly, probability of 4, 5 is 0.3 times 0.2. So when you add those probability, they are going to give us 0.24. 0.24. So that is the probability of getting first number being an even, and then the second one being an odd number. So our last part of B, we need to have the probability of the total score S of the 2 spin greater than or equals to 9. So where we are adding, and we have equal greater than or equals to 9, 4, 5, that is going to be 9. You can have 5, 4, that is 9, or 5, 5 being a 9. So this is a probability of 4, 5, or when you add the 2, that is 9, or probability of 5, 4, that is going to be 9, or probability of 5, 5, which is going to give us 10. Probability of 4 is 0.3, and multiplied by 5 is 0.2. We add probability of 5 is 0.2, and times probability of 4 is 0.3. Then we are going to add probability of 5, 5, 5 is 0.2 times 0.2. So this one is going to give us 0.24. So question number 2, we are going to consider the 2023 Mathematics Paper 2, question number 19 on probability. So the question reads, part A, a number is selected at random from the numbers 90, 91, 92, 93, and 94. A second number is then selected at random from the numbers 2, 3, 4, and 5. Afterwards, a quotient is obtained by dividing the first number selected by the second number. So you have the table here. We have been told to complete the table, complete the probability space in the following table. You have the first number 90, 91, 92, 93, and 94. Then you have the second number 2, 3, 4, and 5. And we are dividing the first number, the second number, and then obtaining the quotient. 90 divided by 2 should give us 45. 45. Then 90 divided by 3 should be 30. Then 90 divided by 4 should give us 22.5. Then we can go to the next one. 91 divided by 2, get 45.5. Then 91 divided by 3, get 30.3. Then 91 divided by 5, you get 18.5. Then you have 92 divided by 2, you get 46. Then 92 divided by 4, you get 23. Then 92 divided by 5, you get 18.2/5. Then you have 93 divided by 3, you get 31. 93 divided by 4, you get 23.25. And then 93 divided by 5, you get 18.3/5. Lastly, we have 94 divided by 2, you get 47. Then 94 divided by 3, you get 31.3. Then you have 94 divided by 4, you get 23.5. Then we have 94 divided by 5, you get 18.4/5. Part B, we are required to determine the probability that the quotient obtained is a whole number. So out of the possibility or the space or the outcome that we have, how many whole numbers do we have? That is the question. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 possibility of a whole number. So the probability there should be 7 out of the total. The total we have 1, 2, 3, 4, 5 times 1, 2, 3, 4. So all of these ones should be 20. So that is going to be 7 out of 20. Then part 2, we are required to determine the probability that the quotient obtained is a recurring decimal. So recurring here, when you look at our space, it's when we are dividing by 3. These others are not going to be recurring. So how many do we have for dividing by 3? So number 1 is the 3rd. Let me circle with red, that one. The other case is where you have 30 and 2/3, and then you have 31 and 1/3. Those are the 3 cases we have the recurrent. So probability should be 3 then out of 20. So part B, we are told that in a shooting practice, the probability that a soldier will hit a target is in the first attempt is 60%. The probability increases by 10% in the second attempt. So the soldier shoots at the target twice. Determine the probability that the soldier will miss the target only once, and then the soldier will miss the target in both attempts. So you're told that the first attempt we have 60% hitting the target, but the second attempt the probability increases by 10%, meaning the first one that is 100% is going to give us 60 hitting. But now the second attempt would be 110, that is 10% of the first one. So we want to know the second attempt, so it's going to be having 110 multiplied by 60 divided by 100, so that one cancels. You get 11 times 6, you get 66%. So that is the second attempt. So we can draw the tree diagram here to be able to see what is going to happen if the person is going to hit twice. So you can have the first case can hit or miss the target. The second case can hit the target or miss the target. If you miss the first case, you can hit or miss the second case. So you can have a hit in both cases. You can hit the first one, miss the second one, or you can miss the first, hit the second one, or miss the both attempt. So hitting the first case, you've been told is 60%, so it is 60%. So missing should be 40%. Then the second case, you are told that the second attempt is increased by 10%. Do we have it as 66%? So hitting is 66%, and of course missing will be 100 minus 66, you get 34%. So the same case here, 66% and then 34%. That the soldier will miss the target only once. Either the hit the first case and miss the second one, or miss the first one and hit the second case. So that is probability of hit the first case, miss the second one, or probability of miss the first case but hit the second case. So this is going to be the hitting the first case is 60%, so 0.6. The missing the second case is 0.34, that is 34%. Then we add the missing the first case is 40%, which is same as 0.4. Then multiply by hitting the second case is 0.66. So when we multiply that, you are going to be having as and adding the 2 is going to have 117 out of 250, or 0.468. Then part 2 of B, the soldier will miss the target in both cases. So missing the both cases is probability, miss the first case, miss the second case. And this is going to be, missing the first case is 40%, so the same as 0.4. Then you multiply by missing the second case is 34%, that is times 0.34. So when you multiply the 2, you're going to get as 17 out of 125, or in a decimal is the same as 0.136. Question number 18, and it reads, 2 bags P and Q contain identical marbles except for the color. So bag P contains 3 green and 4 red marbles, and bag Q contains 2 greens and 3 red marbles. So find the probability of picking a red marble from bag P. Then 2 marbles are picked at random from bag P once at a time without replacement. Draw a tree diagram, probability diagram, to show all the possible outcomes. Part 2 of bag B, find the probability of the 2 marbles picked were of the same color. Then part C, part 3 of B, find the probability that at least one lead marble was picked. Now, let's first answer part 1, A and B, before proceeding to part C. So, we have two bags here, the P and Q, and we're told that P has 3 green and 4 red. Then Q has 2 green and 3 red. So those are the 2 bags that we have. And then you're told find the probability of picking a red marble from bag P. So from P, that's where you get to first consider picking a red from P. So how many red do we have in P? There are 4 of them. Then so the probability of red will be, how many red we have? There are 4 out of the 4 plus 3, 7. So that is just that simple, answering that. Then part B, we are told that 2 bags were picked at random from bag P once at a time without replacement. So we have to draw the tree diagram to show the probability outcomes. So we draw that tree diagram. So from P we have 2 scenarios. We can either get a red or green. So the first pick, let's draw the tree diagram here. So can be red. I can start with green or red, and then the second one can be green or red. This one can be green or red. So in this case, you're going to be having green, 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 red. So now red, green. I can have red, red. We're told that there is no replacement. So when you pick a particular marble, you are not returning it to the bag. So for P, we have 3 green. So when you pick the first case, the probability of green would be 3 out of 7. And then for red would be 4 out of 7. So if you pick green, now you are going to be remaining with 2 because we are initially 3. So you're going to be left with 2. Out of the total now, 6, because you already removed 1. So for the red you have not picked, there are still 4 out of 6. And you can see that the 2 should add up to 1. 2 over 6 plus 4 over 6 should be 1. Now, if you had picked red in the first scenario, now there were 4, so they're going to be remaining 3 out of 6. Then the green you have not picked, so it is still 3 out of 6. So that is very important for us to have to be able to answer the question. So you have answered that one. So let's look at part 2 of B, where you are told now find the probability that the 2 marble picked were of the same color. So same color, here we can have either the green green or the red red. So that is the probability that we are interested with. Probability green green or probability red red. So green green we have as 3 out of 7 times 2 out of 6. We add red red, we have 4 over 7. We multiply by 3 out of 6. 3 over 7 times 2 over 6 should give us 1 over 7 plus 4 over 6 times 3 over 6 gives us 2 over 7. And when we add 1 over 7 plus 2 over 7, this one should give us 3 out of 7. So that's the probability of getting marbles of the same color. Then part 3, we are required to get find the probability of at least 1 red marble was picked. So only one at least one, it means you can have either one lead or two. So in our probability space here, we have somewhere we have either one or two. So we have that scenario, that one, we have one lead, and this one we have one lead. In other words, those are the ones that you need. What don't we need is a scenario where you have two greens. So this one you can do it either we add GR, RG, and then RR, or you get one, subtract GG. So let's work with the second scenario. So probability of at least one, it is either one lead or two lead. So you can have a probability of 1 minus the GG. That one is going to give us is 1 minus GG is 1 over 7. You have it here, 1 over 7. And that one is going to get 1 minus 1 over 7 is going to be 6 over 7. The marbles picked from bag P in B were both put in bag Q. A marble was then picked at random from bag Q. Calculate the probability that the marbles picked was green in color, and then part 2 red in color. So in this case, we need first to go back to our probability of for part B. We're just going to do that diagram again of picking the two marbles from the bag P. We can have the first case as green or red. That is from P. Then can have the second case, green or red, green or red. So this is from P. That's our marbles from P. So we had green was 3 over 7. This one was 4 over 7. Then second case, now because we are not returning, so the deducing, that is 2 over 6, and then this one was 4 over 6. Then same case here, we had 3 over 6, 3 over 6. The third pick now using bag Q, you can either have green or red, green or red, green or red, green or red, can have green or red. So now in this case the probability is going to change. Remember we had only 2 green and 3 red in bag Q. So this was P. P had 3 green and then 4 red. Then in this case we have Q. Q had 2 green, then 3 red. So now when we add 2 greens from bag Q, bag P to Q, our green now in Q there were 2, so they are going to be 4. So in this case the probability is going to be 4 out of we had 5, now we have added 2 in Q, so out of 7. And obviously the other one is going to be 3 out of 7, so that can add up to 1. Then in any case we had picked 1 green and then 1 red from P. Our Q are going to add 2 green will be 3, now 3 will be 4. So picking a green will be now 3 out of 7. And then it's going to be 4 out of 7. So if we have picked red and then green from the bag P. A green will be 3 out of 7, and the lead will be 4 out of 7. Then in any case, the first case we had picked lead from P and another lead from P. Then our number of green are going to remain 2 out of 7. And then the lead, there were 3, then you add 2, you get 5. So 5 out of 7. We are required to have, to answer the question, the probability of, when you now look at the green in bag Q, we are going to pick a green. So where do you have green in Q? This is in Q, so you are going to have either that case, that green, or even that green. So we have those 4 scenarios that you can have green in the bag Q. So let's calculate that probability. So we are going to have the first one, green, that is 3 over 7 times 2 over 6 times 4 over 7. We add the second one, 3 over 7 multiplied by 4 over 6 multiplied by 3 over 7 we add the third case, that is this part here. We have 4 over 7 times 3 over 6 times 3 over 7. We add the last case, that is this part here. We have 4 over 7. We multiply by 3 over 6. Then we multiply by 2 over 7. So when you multiply those 4 scenarios and add them, we are going to have 20 out of 49. This is going to give us 20 out of 49. Now, let's look at the last question, that is now getting a red in color from Q. So, getting a red in color, in this case, these are the reds. Let me put them annexed here there. So, those where we have red. So, in simpler terms, you don't have to do a lot of calculation, because this one can get us now probability of 1 minus probability of green, which we already have that one, probability of green, because we are not interested with probability of green. So this is going to be 1 minus now 20 over 49, and that one is going to give us 1 minus 20 over 29 should be 29 out of 40. So let's consider the 2021 question. It was in section A, question number 12. A box containing 3 brown balls and 9 green balls. Then the balls are identical except for the color, so they look like one another except the color are different. The 2 balls are picked at random without replacement. Then you're required to draw the tree diagram to show the possible outcome. And then part 2, to determine the probability that the ball picks are of different colors. We have 3 brown and then 9 green. So the first pick can be a brown or green. And then the second pick can be brown or green. if you had picked green in the first case, second one can be brown or green. So the outcome here, it is either brown, brown, green, or green, brown, or green, green. The first case is 3 out of 12, and then the green are 9 out of 12. Now, because we are not replacing, we are not returning them back to the box, our second pick, we already picked brown, so we are going to be remaining with 2 out of total 11 because we have removed 1. Now there are 11 total number of balls in the box. Now we have not picked green, so green, they are 9 out of 11. Then we had already picked 1 green, then the remaining one are 8 out of 11. Then blue, there were 3, we have not picked 1, so 3 out of 11. Part B, to determine the probability that the ball picked are of different color. So where do we have different color? It is either brown, green, or green, brown. So that is the probability that we're interested with. So we need probability of brown, green, or probability of green, blue, brown. This is going to be B, G, brown, green, so this part here, so 3 over 12 times 9 over 11, or we add G, that is that part there, 9 over 12, we multiply by blue, that is 3 over 11. The 3 over 12 times 9 over 11, we are going to have as 9 over 44. We add 9 over 12 times 3 over 11, that is 9 over 44. And when you add the 2, you are going to have as 9 over 22. So let's consider the last question on this lesson, that is the 2020 question. It was question number 24. So the question says that the table below shows the number of students in each class in a school. The percentage of the student in each class who wear glasses is shown in the table. So you have the class Form 1, Form 2, Form 3, and Form 4. We have the number of students in Form 1, 60, Form 2, 56, Form 3 we have is 44, and then Form 4 we have 40. Then the percentages in Form 1 who wear glasses, we have 10%, Form 2 12.5%, and then Form 3 25%, and then Form 4 17.5%. So we required part A, a student is chosen at random from the school. Determine the probability that the student is a Form 4. So in this case, there is nothing much here to get the probability that the student is from Form 4, or what in interest Kcse, how many Form 4 are there. So we have probability Form 4. So Form 4, we have 40 out of the total 60 plus 56 plus 44 plus 40, that is the number of students in school. That should give us 200. So that is the probability, and you can simplify that one to have by 41 by 45. So it is a fifth. 2 over number A, the probability that the student wear glasses. So probability that the student wear glasses can have either Form 1 wearing glasses, or a Form 2 wearing glasses, or a Form 3 wearing glasses, or a Form 4 wearing glasses. Form 1 wearing glasses, or Form 2 wearing glasses, or Form 3 wearing glasses, or Form 4 wearing glasses. So Form 1 wearing glasses, first is probability of Form 1. So Form 1 is 60 over 200, the number of students in the school. Then wearing glasses is 10%, that is 10 over 100. Then Form 2, probability of Form 2 is 56 out of the total number of students in school. 200 times Form 2 wearing glasses, 12.5%, that is 12.5 divided by 100. Then probability of Form 3, they are 44 out of the total number of students is 200. We multiply by Form 3 wearing glasses, 25%, so 25 over 100. Then plus probability that you get a Form 4. Form 4 is 40 out of 200. Then you multiply by wearing glasses is 17.5%, so 17.5 divided by 100. See, over 200 times 10 over 100, we are going to have a 3 out of 100. So we're going to have 3 over 100 plus 7 over 200, that is 156 over 200 times 125 over 100. That is going to give us 7 over 200 plus 44 over 200 times 25 over 100. They are going to get us 11 over 200. And then lastly, we have 40 over 200 times 17.5 over 100. This is going to give us 7 over 200. And then when you add the 4 of them, they are going to give us 31 out of 200. So let's look at part B. 2 students are chosen at random from the school. So you have to determine the probability that one of the 2 students is a Form 1, while the other student is in a Form 4. The first pick is a Form 1 and then a Form 4, or we can first pick a Form 4 and then a Form 1. So that is what you can have. So picking a Form 1 is 60 out of 200. Then picking a Form 4 is 40 out of 199. Reason being, the total number of students now you have already picked 1. So they are going to reduce by 1 the total. So it's going to be 40 out of 189. And you're going to add, picking a Form 4 is 40 out of 200. Then you multiply by picking a Form 1 should be now 60 out of 199. Just the same case as picking the first scenario there, because we have already picked up 1 Form 4. Now we are remaining with a total number of the students in the school should be 199. So when we add these two, they should give us a 12 over 189 . plus 12 over 199. And this is going to be 189 plus 12 over 199 is going to give us 24 out of 199. So the last question is that the probability that one of the student is in Form 1 while the other one is in Form 4 and both wear glasses. Either probability Form 1 wearing glasses, then Form 4 wearing glasses, or can have probability over the first student is Kcse Form 4, then wear glasses, or Form 1 and then wearing glasses. Form 1 is going to be 60 over 200, and so from 1 wearing glasses we had 10%, so 10 over 100 times Form 4. Now Form 4 is 40 out of 199 because we already picked one Form 1 there. Then times Form 4 wearing glasses is 17.5%, so 17.5 over 100. So this one we add. The second scenario Form 4 should be 40 over 200. Then you multiply by wearing glasses, 17.5%, 17.5 over 100. Then you multiply by Form 1. Now Form 1 should be 60 out of 199 because I already picked one Form 4. Then Form 1 wearing glasses is 10%, 10 out of 100. So we add the two scenarios. The first one should be 21 out of 19,900 plus the second case is just the same, 21 out of 19,900. 21 over 19,900 plus 21 over 19,900 is going to give us 21 out of 9,950. So thank you very much for your time. I've enjoyed taking you through that part. Goodbye for now.